Welcome back on the short video on chemical engineering statistics. Today, we will discuss about descriptive statistics, which deals with data characterization and presentation. Let's start. Any data measurement can be expressed as a frequency distribution, mapping the frequency at which each sample member appears. Please have a look at the histogram below, which summarizes the mass of each chocolate candy from a single package. Descriptive statistics provides a procedure for characterizing data based on certain quantity of data identifiers. What is meant by certain? Okay, suppose you are asked to describe the physical characteristic of the people standing in the picture on the left. Of course, you will use certain quantities such as height, hair length, fat or thin body, color of the clothes when you observe, and so on. Whether you realize it or not, you will definitely describe these people based on the quantities which you consider to represent the characteristic quite completely. Now, we discussed the dimensions of the data identifiers or data descriptors. The first dimension is the measure of central tendency. This describes the typical or most expected behavior of data. For example, consider the histogram on the right. From the shape of the distribution, you can guess that the center size is inside the following circle. If calculated, the mean data value is 3 and the median is 3 as well. The mean, median, and mode are not always the same, depending on the symmetry of the data distribution as shown in the figure on the left. The second dimension is the measure of variation, which indicates the data distribution. The sizes of the distribution include range of interval, standard deviation, variance, and IQR or interquartile range. Please find a way to calculate these quantities in the literature. The figure on the left shows two data sets that have the same mean but different standard deviation. The greater the standard deviation, the wider the data distribution. The image on the bottom right shows three different datasets. There are pairs of data that differs in the size of their centers, and some differ in the size of the spread. Please watch carefully. The third dimension is the shapes of distribution, which is characterized by several quantities. Skewness states whether the distribution is symmetrical or not. Kurtosis states the sharpness of the distribution peaks, while the number of peaks states how many modes the data has. Again, the formulas for quantifying these quantities are in our textbook. The fourth dimension is outliers, which are data points that deviate far from the group, as shown in these two graphs. We can do outlier detection visually, or if we want to be more accurate, by testing the hypothesis. Outliers can occur due to experimental or measurement errors. If so, then outliers should be set aside in data processing. On the other hand, outliers can also be an anomalous condition, which is actually interesting to be studied further. The fifth dimension is the temporal variation or behavior of the data over time. This behavior manifests itself in time series data, which the process industry is routinely collected by many instrumentation or sensors to ensure the plant is operating safely and efficiently. These two graphs show examples of tracing the behavior of a quantity as a function of time. Of course, if the data you are dealing with is not a time series type, then the dimension of temporal variation are irrelevant. So, very briefly, descriptive statistics characterize the data based on 5 dimensions: sample size, distribution width, shape of distribution, outliers, and data behavior over time. It can be shortened to CV. Which is easy to remember: central, variation, distribution, outliers, and time. That's all, and see you in the next lecture.